Hey everybody, it's Mrs. Peachy from your WCA Earth Science class, and today I'm going to be doing a tutorial for the lab phases of the moon. And this is our second to last portfolio for the school year, Unit 5, Lesson 4. And you will be using an online simulator for this portfolio, which will enable you to see not only the different phases of the moon as viewed from Earth, but also what it would look like if you were able to, fly into outer space and be able to kind of look down upon the Earth-Moon system and what it would look like in that situation. Okay, so first of all, I would like to make sure that you guys are aware of the fact that you need to look at my website for this portfolio, because on my website I do have a template for this one, which I know you guys all like the templates. So if you click on the link to my website, which is available under my message boards, you'll get the home page here. And from here, just click on the Earth Science B link, or the tab here, and then down to Phases of the Moon Portfolio Template. And that should bring you to this document, which you can then download to Microsoft Office. Okay, and when you do that, it's going to give you some sections to complete. You're going to want to include your name here, not just the word your name. And you're going to tell me why you think there's phases of the moon. So you're going to do this before you even start the actual simulation. So I want to know, what are your thoughts? What did you think caused the phases of the moon? And then talk about the moon phases a little bit. Then do a little bit of research in your textbook and tell me a little bit about the different names of the phases of the moon and what they look like. And maybe you can talk a little bit about like the length of the cycle of the moon phases and that kind of thing, okay? So that's going to give you that introduction and hypothesis section. Next, you're going to explain how you use this moon phase gizmo. So yes, that's the material that you will be using, but you're going to explain what to do with that gizmo. What are you looking for? What are you drawing pictures of? And, how do you go about using that gizmo? So this section can be listed. You can be number 1, click on the moon phase gizmo in the Earth Science lesson. Number 2, when you get to the moon phase gizmo, you're going to see blah, blah, blah. So you can kind of give a little bit of an instructional list, kind of like you would if you were doing a recipe for making something, and you're going to give us the details of what to do. You don't just list the ingredients, but you also have to list the directions. So you can think of the methods section as being the directions part of the recipe. And the materials section is kind of being the ingredients part of the recipe. Okay? Lastly, well, I shouldn't say lastly, but nextly, you have your data. And I'm going to explain what this is in just a moment, because I've actually done one of these for you, and you are going to do 1, 2, 3, 4 more of these. And then you're going to answer the question, after doing this lab, now what do I think causes the phases of the moon? And then from activity A, you're going to do questions 4 and 5. And from activity B, you're going to do questions 2 and 3. And again, I will kind of explain what that means when we look at the gizmo. So let's go to that little gizmo, shall we? Let's see here. All right, so let me just go to the bottom corner so you guys can see what page I'm on. Okay, so here it says, click on the link below to complete the Phases of the Moon gizmo. The exploration guide found within the simulation will help you work through the gizmo. Click on the Lessons Materials link, which appears at the top left corner of the screen once you enter the simulation, to access the student exploration sheet. Use it as you work through the gizmo. Warm up Activity A and Activity B. You are not responsible for completing the extension portion. So that's pretty much what I've said as well. We're just going to do some selected questions from activities A and B, and I'll kind of walk you through, what you're going to be looking at using the gizmo itself. So let's click on that link and see what we see. Okay, and at the top of the screen, you're going to see right here, you're going to see where it says lesson info. And what you're going to want is student exploration sheet. Okay. And really the reason why you're going to use this is primarily for the questions. It's going to give you directions as well, but since I'm not having you turn this in, let me say that again, people. I am not having you turn this in. You're going to be turning in the completed template to me, not this. So please don't do that. Don't turn this in to me because I will just resubmit it to you because I do want that template. It's much more to the point. So, you know, it's going to ask you to do some things. It says in the phases of the moon warm up, click on the play button and watch a simulation. You're going to look at what's going on and kind of make some, you know, observations and maybe some guesses or hypotheses about what you think is happening. And then we go to question in the first part of activity A. And this is pretty much your hypothesis, what I kind of mentioned to you earlier. So it says, why do you think we have phases of the moon? So again, that is your hypothesis. And then it also says in here, it says, click play as the moon goes around the Earth. Notice what the moon looks like on the right side of the gizmo. This is what an observer would see on the North Pole. And then it says, turn on show view area to see which part of the moon is visible from Earth. So let's just look at this because I think it's a little easier for us to look at rather than just read the directions here. And I'm just going to get this little thing out of the way. And I probably should just get me completely out of the way, but. All right, so let's see. Let me go down just a little bit here so you can see the bottom. And let's notice the sun. Now, hang on a second, Mrs. Peachy. The sun is teeny tiny. That doesn't make any sense at all. Why would the sun be so much smaller than the Earth? Well, remember, it's not at all smaller than the Earth. The sun is so big that, you know, I think it's like 1,000,000 Earths or something fits across the sun. It's a lot. But it's far away. So we're looking at kind of a scale here. It's far away, right? So let's look on, excuse me. Mrs. Peachy just made a stupid mistake there. This is actually the moon. The sun is off the screen. Sun is to the right and very far away. So it is very far away, but this is what the moon looks like. So, and whatever. I'm not re-recording this to make that sound better. So, stupid little mistake on my part. That's the moon. Here's the Earth. And let's push play here and watch what's going on. See this is we're looking from the North Pole, right? So we're looking top down, which is important. So look at how many days are passing, right? On the bottom, you can see gradually we're seeing more and more of the moon appearing. Oh, let's pause right here a little bit. So remember, if I'm standing at the North Pole, this is what I'm seeing, right? If I'm standing at the North Pole, what would I see? I would see the moon changing in phase depending on where it is in the sky. Now think about this, right? I'm only going to see the moon. Well, you can see the moon both during the day and at the night, right? So you got to remember that as well. It's not like a star where you only see it during the nighttime. It can be seen both day and night. So depending on where you are, it can be day or night, and you're going to be able to see that moon phase depending on where the moon is in relationship to you. But it's going to stay there for many, many spins of the Earth. So if you watch the Earth spinning, the Earth spins way faster than the moon is moving. So one particular moon phase, it won't be exactly the same from night to night, but it's going to be very similar. It's going to change really, really gradually over time. Okay, so let's just reset this whole thing. And let's look at what it tells us to do in our document template. It asks you to draw what the moon looks like on day 7. Well, first of all, we said day 1, which I kind of did for you already. This is when viewed from space, and this is when viewed from Earth, and this is the moon phase. And you're going to get those phases of the moon. Let me see here. It'll say it right underneath, okay? So what we can do, I think, let me just double check. Nope, can't, never mind. Thought maybe we could just click in the box and type it. What we're on here right now is we're on day 1. Well, day 0 actually. But I mean, I seriously could get me the heck out of the way there. I'm almost there, right? Okay, it's pretty much, you don't have to be precise, okay? You don't have to be exact. Be precise, but don't be exact. So what do we see here? From space, the moon is lit on the right side and dark on the left side. From the Earth, it's black. We're not seeing anything, and it's called a new moon. So that's what I did here. From space, lit. For me, lit is just white. Some people don't like that. They're like, that looks like you're not coloring it in, therefore it must be dark. My suggestion, hang on, this is my office version. You could, for example, take, let's see, insert. If this helps you, you could like do shapes and then the little scribble, and then I think that's what I wanted, right? Nah. This one, this little scribble. And then I get a line here and I can color it in. No. Didn't work. Uh-oh. Maybe I can do a half circle. Maybe I can do a little half circle and I can just like insert that in here. And then flip it around. Beautiful. It's actually not beautiful at all, but I can kind of squish her and make it fit best I can. Okay, obviously my sense of spatial awareness, yikes, has some, I need to do a little work here. This is not super pretty. But since I'm limited on time here, I can't spend a ton of time like showing you what to do there. But I can change that color if I want to say something that is more representative of light. We want to make it orange, or let's say we make it bright yellow. Okay. Ta-da! Then it looks more like it's a half. It's lit up on that side. If you want to do that, if you don't, just color it in with black, and white represents the fact that it's lit up. That's my opinion. Okay. All right, so you're going to do that for days 7, 14, 21, and 28. Then, when you're all done with that, you're going to go ahead and answer the questions on activity A and B. So let's go to activity, no, that's not it. Let's go to activity, nope. I lose things rather easily, don't I? Here it is. So let's go back to the student exploration sheet, and we can go to activity A, and I think it said questions, I don't remember, so I'm going to check. Questions 4 and 5, that's what I thought. So questions 4 and 5 says, look at the overhead view of the moon and the earth. How much of the moon is always lit up or illuminated by the sun? I'm not going to give you the answer to that question, but I want you to think about it. And B, can we always see the same amount of the illuminated side of the moon from Earth? So if you're standing on Earth, are you always seeing the same amount of that lit up portion? And then question 5 is, why do you think we see moon phases now based on your observations? And then 2 and 3 here, it says, suppose you saw a waxing gibbous moon. What phase would you expect 1 week later? 7 days later, so then test that using the gizmo. And 3, waxing means growing and waning means shrinking. Seen from the North Pole, which side of a waxing moon is illuminated? Which side is illuminated when the moon is waning? Suppose you see a crescent moon, how do you know if it's waxing or waning? So think about those terms, waxing and waning. Waxing means getting bigger, so it's more and more lit as the days pass, and waning means it's now getting smaller. So think about those questions. If you have any additional questions or concerns, you can give me a call, extension 2204, or send me a webmail message. Good luck, everybody.